So this is basically what we're going to demo today. So I've showed you how Happy Harold can get the config files from his laptop onto the node through that secure provisioning system. And what I'm going to insert in between is GitLab. So this is just using a free account I created, as I said, a couple of weeks ago, and have been hacking on for the last couple of weeks. Basically using GitLab to front end the configuration management, to front end the Git repository, but also to leverage their pretty cool CICD they got built in, which is super easy to use. And it's probably worth mentioning before I go on, the whole process is happening 100% out of band. The demo that I'm showing, full disclosure, is virtual. I'm not actually doing a real infrastructure. But basically, you don't need any kind of LAN or WAN connectivity in place to use this cloud GitLab account to be able to provision a new switch. So it could be completely disconnected from anything except for that provisioning node. So basically, this is what my pipeline looks like. The user, and there's a URL down the bottom if you want to browse there and have a look at the code. That should be open up to public. For public viewing, and if it's not, do let me know. So the user basically commits the switch config into GitLab. That triggers the CI/CD pipeline in GitLab. The first thing it does is it does that automated testing phase, and it's just I've just implemented a couple of trivial linters to make sure I haven't made any really bad typos. Then GitLab, once those tests pass, it'll go into the continuous deployment, the CD part, the deploy phase, and it'll push the config file to Lighthouse. This in turn kicks off our internal pipeline, which is basically an Ansible playbook, and that will push the configs, basically using that manifest, that YAML manifest that says which configs should go to which nodes, down to the nodes, and orchestrate setting up the DHCP services, the file servers, and things like that. And for extra credit, I've actually added into the CI/CD pipeline an extra step. Step 5. I've got some codes and a little Python extension. I've written a little bit of code I've written using the NetMiko library to log in out of band through Lighthouse, over that cellular connection, through the other node into the console, and reinitiate the ZTP process on the switch I'm trying to provision. So it'll basically correlate the file name with the console name, which corresponds to the host name of the device. So. And that basically, what that means is I can check in code and I can either initially provision this switch or I can actually re-provision it from scratch as well. So that's my PowerPoint. So let's jump over to the demo. So I'm not sure if you've had a chance to log in yet, but that's what you'll see. Basically, this is my GitLab project, and that should be open for the public, so anyone can go and log in and check it out. And let's just have a look at some of the files. Jump in. So I've got a couple of different directories here. I've got the NetOps directory, and this is all the code that pertains to the secure provisioning, the configuration of secure provisioning itself. I've got this directory here, which is CICD, and this is all the code that pertains to the GitLab part of the demo. So having a look at the NetOps side. As I said, there's actually an easy mode UI, so you don't actually have to be necessarily interacting with Git and writing, crafting YAML files and things like that. You can just jump over to our Lighthouse GUI, and I'll just give you a quick tour of the GUI because that helps introduce some of these high-level kind of concepts, I think, pretty nicely. As I said, the NetOps modules are Docker modules that you can activate and deploy, and when you do that, they actually are kind of you don't have to upgrade the Lighthouse system. It'll basically run a new container inside Lighthouse that presents its own little API or UI snippet. So what that means is basically I activate secure provisioning and I get a new menu item pop up on the side. And I've got device resources. I've just got a few defined here. As you can see, there's a bunch of configuration files associated with each device. Let's have a look at this one here. And some of them are ending in J2, which is the Ginger 2. Since we're using Ansible under the hood, you can actually take advantage of that and do some templating using Ginger 2. Here's the list of devices that we support. As I said, each of these ZTP implementations are different. Some of them use different, some of them use TFTP. Well, really just classic iOS still uses TFTP. Most of them use HTTP or HTTPS now. But some of them use intermediary scripts. They expect different DHCP options and things like that. So we basically abstract all that away and we say, okay, just tell us what the device is, and we've already got a template for that. So at the moment we support Arista, HPE, a classic iOS, iOS XR. We've just added support for XE and NXOS as well, but this is a bit of an older build that doesn't have that. Huawei, Cumulus, Juniper, ourselves, and Pico8 as well. So you can just upload through the GUI your config file, an image file, like a firmware, a software image file, like an iOS binary file. And here's where you can define a bunch of MAC addresses that's associated with the lease, or a range or a wildcard or a reverse match. And since this is iOS XR, you can also do the serial number too. So obviously, if you're doing this kind of at scale, you're not going to be sitting in the GUI and clicking, and adding MAC address after MAC address and things like that, which is where the Git workflow comes into its own. But I think this is just useful kind of as a primer on how the whole thing hangs together. So that's the device resource bundles. That's what it takes to get a particular class of device up and on the network. The other thing we have is these distribution policies, so which nodes are going to host which device resource bundles. So I won't talk too much about this, but there's basically, you can have a static list of nodes, which nodes get which resources. But you can also hook into the Lighthouse smart groups. So when an Opengear node, when one of our management appliances enrolls itself into Lighthouse, it can actually get tagged with a bunch of metadata. Things like its location, what group is managing it, things like that, is where it is in the data center and things like that. And you can use that metadata to dynamically add it to a group. So basically it's kind of like an email filter or something like that. And then you can link one of those smart groups to a dynamic node inventory. So that means when you enroll a new node, you don't necessarily have to go changing all your configs. It will just automatically push the appropriate device resources it needs for that class of site. So that's basically our system as presented in the GUI. And that corresponds to this downloads directory here. So these are all the config files. And here's my super trivial Cisco configuration, initial configuration. And the config.yaml is basically what defines the resource distribution, so which nodes get which resource bundles. So the other thing I'll show you.
Is your config completely dynamic too? So can you change the host name to be based on the site or any other preferences?
So these are arbitrary. You can make these names whatever you want. In my demo, it is actually meaningful though. I'm actually saying, well, the config name should match the console label, because I'm doing that extra step of going and logging into that console, and I'm resetting that console with that particular label. So whether it's meaningful or not is up to you. In terms of whether we automatically generate it, no, it's something you type in through the UI or you craft through the YAML.
Okay.
Yeah.
But that's pulling it into the iOS configuration that's getting put on the device?
Right. I'm not sure if that's available as a templating variable. That's a good question through Ansible. It should be, but I'm not.
Oh, you're doing it all through Ansible?
Yeah, that's
okay,
right. Yeah.
Gotcha. Sorry.
Yeah. Cool. So yeah, that's basically the main YAML file that defines how these resources should go around the network. So one extra thing I did a couple of years ago when I came and first introduced Lighthouse here at Tech Field Day, we just had our first kid. I did this kind of ChatOps integration. I don't know if you remember, with the Slack integration. And there was a little Easter egg where you could get it to tell you a dad joke. So I thought, well, we've got 2 kids now, so I need twice the number of dad jokes. So what I'm going to do is I'm going to put a little custom Ansible task in here, and that gets pulled into our playbook, and that's going to dynamically go and pull a dad joke from Mike and Has dad joke and make that available as a templating variable. So the other thing to have a look at is under the CICD. So this is the GitLab code, and this kind of does all the heavy lifting. So this is basically this is the main config file for the CICD. So a few stages here. So this is the linting stage, the test stage. Basically, I'm pulling in, I think, the Cisco conf-pars library from Python, and just making sure I've got things like interfaces set and username and stuff like that. It was a really trivial config file, so obviously it's not that heavily linted. And also YAML, just to make sure that indentation's all right, because YAML's kind of finicky about that. And I also have a Python linter here, which I've disabled because, frankly, my Python code is atrocious and never passes. So, and here's the CD part of it. So this is the deployment phase here. So basically what this is doing is it's authenticating. It's basically, I've defined a private key in the CICD environment that gets pulled in that allows it to authenticate itself with the Lighthouse Git repository. And it can basically clone the secure provisioning Git repository back to GitLab and then make any of its changes in place and then push them back to to Lighthouse. You can do it this way, or you can actually just get GitLab to directly mirror to the Lighthouse repository. I've chosen to do it this way because you get to see it kind of all happening in the CI/CD window, and it makes a better demo, basically. So you can basically, this first little bit here checks out the secure provisioning repository. It propagates any changes to the secure provisioning repository, and then it checks it in. So at this stage, if we kind of just jump back to, so you committed in, done the linting, pushing the config, and this is where it kicks off the Ansible phase. So basically, having a look here, once you've checked it in, we'll see the output from Ansible running on Lighthouse. And then, as I said, the third little bit that I've done is this deploy script here. And this is the netmiko script, so completely optional. You may not choose to have your automation system automatically go and reset the configuration of all your switches, or you may, like me, since I'm pushing the big Leroy Jenkins button. But basically, that's what this does. It logs in through the console name that corresponds to the config file I've just checked in. Again, all out of band, all through the cellular connectivity, so you don't need to have actual connectivity into that site, and it runs a command to put it back into ZTP mode. So yeah, let's do it. So I'll make a couple of edits to the config just to make sure that they get propagated. Let's have a look down here and just update the message of the day. So let's put in a warning, dad, joke follows. Okay. And I'll update the distribution policy as well. So my inventory is currently empty, so I'm actually not pushing any resources to my remote provisioning node, which is why right here I've got a console that's basically sitting there. This is an iOS XR, virtual iOS XR, basically sitting there in ZTP mode, waiting to get some configuration. So let's say I've defined this configuration file here, the one that I've just edited the message of the day for. And that's called demo_xrv. Done. And let's commit that change. Yeah, that looks good. That looks good. And commit. And update the message of the day, my highly meaningful commit message. Sure, I'd get yelled at if I tried to commit that into production, but let's do it. So basically checking this in is going to start the CI/CD pipeline. So let me click over here, and cool thing about GitLab is, if I can find the right menu, let's go back over here to CI/CD pipelines, is you can actually watch this run in real time. So the linters aren't that exciting to watch, basically. So for each of these CI/CD jobs, GitLab starts up a little Docker container, and you can tell it what image to use and what code to pull in. And here I'm just pulling in a couple of requirements. Here we go. And it's basically running the linter. So it's pip installing the requirements, which is Cisco conf pars, and hooray, that worked. Let's go back to pipelines. So that should be a big tick. It runs them in parallel, which is nice too. Pipelines. So these are done, and this is kind of where the interesting stuff happens. So this is doing the deployment phase of the pipeline. So we actually should see things happening both in our console inside GitLab. We'll see everything that Lighthouse is telling GitLab back when it's doing the git push, and it's doing running the Ansible playbook. So we'll see the output there. But then we'll also see GitLab logging in using that deployment Python script, the netmiko script. We'll see it logging in through this console and resetting as well. So this takes about 2 minutes. So now's a great time to ask any questions. These ZTP demos are always really awesome to do because
it's always nice to see a lot of green.
Yeah, well, that's right. Yeah. That's why I thought I'd make this console red, just to, just for luck.
So I was just trying to think through use cases. Is there a killer use case? Like, what's like maybe your top killer use case for this?
Yeah. So the one use case, or the main use case where we're targeting is when you're basically deploying a new kind of edge data center where you don't, like in greenfield, and you don't really have anything there already. So you don't have your WAN link configured, you don't have your LAN link configured. So I guess so some of our customers say they kind of had all these cloud servers, but now because they're trying to get data cached and stored closer to the actual consumers of the data, they're actually running. Some of them are repurposing these little kind of telco huts and things like that as little mini data centers. So turning up a site like that is you can just drop one of these boxes in. In terms of whether you want to do that through GitLab, that's maybe debatable, but certainly you can do it through Lighthouse directly. So the reason I chose GitLab is because it's super cool. So yeah, you can see this is the output of the console, and that's basically run. There you go. It's reinitialized the ZTP process. And some devices you'll actually have to reset the config, but the reason I chose to demo with this one is because you can just reinitialize iOS XR ZTP, and then it'll kick on. So again, this will take a little while.
So I have a question while we're waiting for this to finish.
Yeah, sure.
Is this, obviously we're talking about ZTP here, but is there any way for config validation and ensuring state? So the idea is, we have this particular set of config, right? Is there any way to, obviously we can do that with Inband, but the question is, what happens if somebody changed something that was, that caused it to go offline? Mm-hmm. It's not your desired state. Can we then push that state back without doing the whole ZTP process? Is there any monitoring piece in that, or?
Yeah, so not currently. So currently we're like really a configuration delivery kind of mechanism. Having said that, we're starting to implement a bunch more features to make it a bit more sophisticated. One of them that we've just added in the release that's coming out at the show that also adds the XE and the Nexus OS support is being able to run arbitrary post-provisioning scripts. So basically, once it's done the provisioning, it can go and first of all, it generates some keys, SSH keys inside the remote part of the system in the remote container. So that basically authorizes the node then to go and log in via the SSH. So you can kind of log in. You can template the public key into the configuration that you're pushing, so you can authorize the node to go and log in, and then you can go and do things like check state. At the moment, it's kind of up to the user to implement that. It's just like a hook. But I imagine as we kind of flesh this solution out, because this is something we've kind of really just launched and we're kind of showing off the platform, then that's certainly something we could look to do.
Okay.
Yep. So yeah, thanks for the question, because that bought me just enough time for the demo to finish. So as you can see, the configuration, the ZTP has processes run on the iOS XR virtual switch, and it's exited successfully, which means root. Let's exit. And so I've got a host name now, and if I exit, there you go. I should have my message of the day there, and I have. Yeah, I'm not even going to dignify that with reading it out. But there you go. It's inserted the dad joke that it's pulled from Mike and Ha's dad joke. So I guess that's just like an example of how you can use an off-the-shelf automation system, and you can quite easily hook that into your out-of-band management network. So that GitLab cloud account doesn't, it's not concerning itself with how it's reaching all this infrastructure. It's literally just pushing config, and we're kind of taking care of the rest. It's also a little demo of how you can do a bit of dynamic configuration generation through using some of that Ansible templating, which is why we chose to build this on standard kind of DevOps DevOps type tools because it just gives you so much power. So, was there anything else anyone wanted to kind of see in terms of the demo? These ZTP demos are basically always really exciting, watching lots of stuff scroll past and, hey, look, the config here is now the config there. Otherwise, I can jump back and.
I do have a question about Lighthouse.
Yeah, sure.
How's it licensed?
So it's like a yearly license. So it basically is a VM. So we provide that for you to run wherever you want. You can run that on-prem or you can run that in the cloud. But basically, you control you run the VM wherever you want. The software itself is licensed yearly. So it's licensed on a per node basis. So based on how many Opengear boxes you have enrolled in Lighthouse. So there's a couple of different breakpoints in terms of how that's licensed. The secure provisioning and the NetOps modules are licensed separately, so they're actually add-ons to Lighthouse.
Do you have node and feature licensing?
Basically, yeah, effectively, yeah. The other thing we have, and we just introduced, is Lighthouse Enterprise. So that's kind of like it gives you a couple of extra features. One of those is the multi-instance, so you can run multiple Lighthouses and have the nodes connect kind of in a high availability type configuration. And it also gives you a new feature which we're calling remote IP access, which, as you can guess, gives you remote IP access. Basically runs a VPN service on Lighthouse, so you can run a client and VPN into Lighthouse, and it'll actually bridge you over that cellular connection that the node's establishing back into Lighthouse, and it'll basically give you an address, your client an address on that remote network using a layer 2 bridge over the Lighthouse VPN.
And do you have the like an LTE modem built in, or is it go get the USB stick from your provider?
Sorry, the LTE modem?
Yeah, for the cellular backhaul?
Yeah, so all of our models have the option of having cellular, apart from, our biggest selling models, the IM7200 and ACM7000, they all have a cellular, and also so does our new operations manager models as well. So they've got the option to have the embedded LTE, and also now LTE Advanced with the global deployment capabilities embedded in the appliance itself. So yeah, that's something that we kind of do uniquely, because going through all those certification hurdles and things like that is a bit of pain, but actually at the end of the day, you've got like a purpose-built, you're not having dongles hanging out, you don't have two devices to worry about in terms of your remote management. You've got this self-contained box that's kind of highly available and highly connected and highly resilient. So,
although we presume we're still sticking a SIM in it though, right?
That's right. Yeah, it's BYO SIM. Yeah, we don't do airtime or anything like that, but we support all the major carriers worldwide, and Verizon, AT&T, and all those kind of things. So,
do you have an antenna extender to get it out of the big metal rack?
Yeah. So basically, it's got like little SMA connectors on the box, and you can just run. Basically, we have a little magnetic one that sometimes all you need to do is get it out of the cage, and that's enough. But you can also, if you're really like in a bunker or something like that, you can run some low loss, LMR 400 or something like that, and you can get an antenna and put on a big Yagi antenna or whatever you like. So. Yeah.
Well, that's always been my question, because I often think about like the use case of putting these in colos.
Yeah.
Right, because who wants to go out to the colo, to fix something? But the colos are almost always cell phone dead spots, especially if you're in the middle of a colo. It's just all the metal, all the stuff that's going on. They're essentially Faraday cages. And so, like, do you have customers who have solved that problem inside of big colo spaces? I mean, is it just a big antenna, or is there?
Yeah, so I mean, there's a couple of things. We support multiple carriers, so often it's just the case of which of the carriers has like the lowest frequency that's actually getting into that colo. The other one is sometimes it's just a matter of getting that antenna just on top of the rack kind of thing. But yeah, certainly we have a lot of cellular deployments inside colocation.
All right.
There was a question in the Twitter feed about why would they decide to do NetOps Automation out of band rather than in band, right? So in software-defined networking, when you combine, basically what we are doing is collapsing, not we, but what the industry is doing, collapsing the management plane with the data plane. And every time you do that, if there is a network outage or disruption, you lose the ability to manage the network, as Rob mentioned. So we believe doing certain things, provisioning, out of band, is not going to be only an emergency situation. That's the right way to do things, because every time you collapse management with data, if there is a network disruption, which is exactly when you need to manage, you lose the ability to manage, right? So out of band is no longer for emergency only anymore, as companies are pushing infrastructure to the edge, and you're building data centers in a cell tower, or you're putting caching, video caching servers very close to the last mile. Companies need to deploy equipment and servers very close to the end user, and every time you do that, you run the risk, if you collapse data and management, you run the risk of not being able to access, to manage exactly when you need it. So Opengear is evolving our system not to be just an out-of-band emergency management system, but to be a resilient system that works all the time for software-defined networking.
With some of the automation that you alluded to and the emergencies that you just brought up, in those situations, if I have an Opengear box on site and I lose that network connectivity, can I go ahead and trigger actions from the Opengear device itself? Go ahead and make this change on the router. If that doesn't work, go do this kind of stuff, or?
Right, yeah, so that kind of speaks to the runbook automation that we have built into our products. So they can actually act completely independently of any kind of other connectivity. So yeah, that's the kind of thing we talk about with smart out-of-band. So you can run arbitrary scripts that are testing for things that might be as simple as just pinging. One of the classic ones, if something stops responding to a ping, you just power, you just bounce a PDU outlet and bring it back. So that's one way to do it. So yeah, but you can certainly make that a lot more sophisticated and kind of chain together multiple actions. What we've found though is, I guess, like that automation. I mean, the capabilities are there, but I think the power of automation comes in the centralization and being able to kind of do things from a central point where you've kind of got all that context, and you can say, well, it's not just this site's gone out, there's a whole bunch of different sites. You maybe correlate and say, oh, okay, it was actually this configuration change that this person made that's brought down, all my West Coast sites or whatever it is. And in that context, what you really need is that resilient connectivity from the node back to your central automation software. And that's what, I guess, when I'm talking about this out-of-band fabric, that's what it's doing. It's kind of extending the reach of these automation tools so they can operate in-band and they can make those changes. But if something goes wrong, or indeed, as Marcio said, just as kind of best practice, you can actually just do everything over the out-of-band network, knowing that connectivity is going to be there. The automation tools are still going to be able to reach the devices, even if the WAN's down, even if the LAN's down, kind of thing. So,
thank you.
Can I ask a question about your Lighthouse adoption? It's like from your customers. How many of your customers would you say are actually running Lighthouse? And how's the adoption coming? And how fast are new customers ramping up on it?
Yeah, sure. So, I mean, we really kind of launched Lighthouse 5 probably a couple of years ago. And since then, adoption's been pretty positive, given that we've come from really just being a hardware vendor, and the central management and selling software is kind of maybe a bit new, certainly new to us, but new to our users as well. Adoption's still kind of like, maybe less than 10% for new sales for our install base, but it's growing all the time. And I think things like being able to run the NetOps Automation platform is really driving adoption of Lighthouse. So.
And you said you launched 5 when?
Lighthouse 5 was launched, I think it was like Tech Field Day.
It was exactly 2 years ago.
2 years ago, yeah.
2 years ago.
Yeah, so this is where I came in and showed the RESTful API. So just to wrap up really quickly. Networks, I guess the topology of networks and network operations are changing. So out-of-band is changing with it. So out-of-band management used to be really about connecting a human operator to a single device CLI. Out-of-band management really is now about connecting all of your best practice automation tools to your entire network infrastructure in a secure and a resilient way. So really that's what the NetOps Automation platform is about. It's about making that available as an application fabric, so code can run over the out-of-band network, and also making these automation type applications accessible to these users that are kind of struggling, or they're wondering how they can get started on that automation journey. So, thanks. Any other questions?
Last comment in provisioning, we are providing the application, but again, we are making the platform available so any software management tool can access the edge of the network transparently and without being locked into a proprietary scheme. It's just transparent connection between the automation center and the edge of the network, and we think that's going to be important in the future. Again, any management tool needs the resilient access to the edge, even when the production network is down. And I think it's going to become very apparent that having that out-of-band path is going to be important, not only for our applications, but all the other management tools in the industry.